So today I'm going to do some questions on normal distribution with hypothesis testing. I'm going to do 2 questions and I will do more parts in future. So without further ado, question 1. A machine puts liquid into bottles of perfume. The amount of liquid put into each bottle, d milliliters, follows a normal distribution with mean 25 milliliters. Given that 15% of bottles contain less than 24.63 milliliters, find, to 2 decimal places, the value of K such that P, so probability, 24.63 is less than D, which is less than K, which equals 0.45. Okay, so with these questions, especially for normal distribution, you have to always look at the information they give you and what they don't give you and work from that point and try and find all the gaps. So for example, your mean, your standard deviation, your area, etc. Right? So this is our normal distribution here and how it is modelled, and we've got this mu, which represents mean, and we've got this lowercase sigma, which represents standard deviation, and the squared part obviously represents variance, because as we know, standard deviation is variance square rooted. Okay, so using this information, what is our mean? It says here that our mean is 25 milliliters, and our standard deviation is, well, we don't know, so we'll leave that blank, and then we can do d to n because obviously it says d milliliters. And then in the next part it says given that 15% of bottles contain less than 24.63, so we can say probability of d being less than 24.63 equals 0.15, because this is also percentage to decimal. So this is our information. This tells us that the area to the left of 24.63 is 0.15, so to the left. Okay, then we have this part here, probability 24.63 less than D less than K, and we are trying to find K. So this equals 0.45, and that tells us the area between K and 24.63 is 0.45. Okay, so between this is 0.45. So the total area to the left of K is 0.15 plus 0.45, because obviously this here, the 0.15 is telling us this is the area to the left of 24.63, and this is the area between 24.63 and K. So if you do everything to the left of K, it will be this plus this, and that will give you 0.6. Now what we need to do, like I said before, is when the question doesn't give us the full information, such as the standard deviation, we need to find it. So yeah, let's find standard deviation. When we're trying to find values, we're going to use inverse normal in our calculator. So in my calculator, that would be distribution and then inverse normal. And you get the area, you get standard deviation and the mean. So for area, we're going to put 0.15. And then when we don't have our values, we put standard deviation as 1 and the mean as 0, and that will give us our z value, and z equals minus 1.036. You can pause this and do it in your calculator. And now using this information of our z value, we can plug it into this equation here, and that will give us our value of standard deviation. So minus 1.036 equals 24.63, we know that to be our x or d value, minus mu, which is 25, obviously we did that earlier, over standard deviation, multiply that out, and then keep minusing, and when you do minus 0.37 over minus 1.036, you'll get standard deviation equals 0.357. Now we've got our standard deviation value. However, that's not what we're looking for, right? We're looking for the value of K. So to find K, we're going to do inverse normal again, and this time we're going to use the area we found earlier for the total area less than K, or to the left of K, which is 0.60. Our standard deviation we now know is 0.357, and our mean, as said earlier, is 25. And when you do this, you get K equals 25.09 milliliters. Okay, a random sample of 200 bottles is taken. Part B. Using a normal approximation, find the probability that fewer than half of these bottles contain between 24.63 and K milliliters. Alright, So what we're looking for is probability of the bottle being between 24.63 and K, which equals 0.45. Now we do this because it says fewer than half, so it's going to be less than 0.5. Now, let's look at the information in this question. This random sample of 200 bottles is going to be our N value. And we have our probability here, which is 0.45 roughly. And we can actually say that if N is large, which it is, 200, and P is close to 0.5, which it is, the binomial distribution can be approximated by the normal distribution, where mu, or mean, equals N times P, and standard deviation equals the square root of NP bracket 1 minus P. So let's work out these values. We have modelled our binomial distribution here. This is our N value, this is our P value, and then mu, or mean, equals 200, that's your N, times by 0.45, which is your P, and that gives you 90. For standard deviation, or variance, you get 90, bracket 1 minus 0.45. You expand that and you get this, and then you get variance equals 49.5. And if you square root that, you get your standard deviation, which is 7.036. Now, to do fewer than half of 200 is 100. So we need to find out the probability that it is less than 100, right? In your calculator, do normal CD. Something like this should come up. For your lower value, you're going to do minus 9,999. We're basically trying to find the smallest value possible. So this is a very small value, which you would put. And obviously, when you're doing upper, you would do 9,999. But in this case, our upper value is 99.5 because that is slightly less than 100. What we're trying to find is fewer than half, okay? And then our standard deviation here is 7.036, and then our mu value, our mean value is 90. And that gives you 0.9115. And that is your probability that fewer than half these bottles contain between this. Okay. The machine is adjusted so that the standard deviation of the liquid put in the bottles is now 0.16 millilitres. Following the adjustments, Hannah believes that the mean amount of liquid put in each bottle is less than 25 millilitres. She takes a random sample of 20 bottles and finds the mean amount of liquid to be 24.94 millilitres. Part C. Test Hannah's belief at the 5% level of significance. You should state your hypothesis clearly. Okay, so this is the actual hypothesis testing part. So the same we do with any hypothesis testing question, we're going to set out our null hypothesis. In this case, that is mean equals 25. And then obviously it's saying that the alternative hypothesis is actually believes the mean amount of liquid put in each bottle is less than 25. So when you have this less than value, it's either less or greater than value that indicates a one-tailed test. Okay, so we can say that our alternative hypothesis is the mean is less than 25. Okay, and then our question tells us that the sample of 20 bottles and sample mean is 24.94, so we can say that our sample mean is 24.94. Our n is 20, we know that here, and our standard deviation, as said here, is 0.16. Now we're going to work out our standard error, that is standard deviation over square root of n, and that gives you 0.035777. You always need to work this out because that's what we're going to use in our normal distribution. Okay, so now to find the p-value, we're going to do probability x is less than 24.94, that's what we're looking for. And in your calculator, you're going to do normal CD, and this is what's going to come up. For your lower value, you're going to do a very low number, minus 9,999. For your upper value, you're going to do 24.94, as shown here. You've got your standard deviation here, and your mean is 25. We know that from here. And that will give you p equals 0.0467. Okay, now we need to compare this to our level of significance, and it says here that that would be 5%. 5% as a decimal is 0.05, and p is actually less than that. So 0.0467 is less than 0.05, so we reject the null hypothesis, which means we accept the alternative hypothesis, so we can say that there's enough evidence, sufficient evidence, to back Hannah's claim. Question 2. A machine cuts strips of metal to length L centimetres, where L is normally distributed with standard deviation 0.5 centimetres. Strips with length either less than 49 centimetres or greater than 50.75 centimetres cannot be used. Given that 2.5% of the cut lengths exceed 50.98 centimetres, find the probability that a randomly chosen strip of metal can be used. Okay, this is not our hypothesis testing question, but that will come in the last part. So the first thing that we're going to do is we're going to do our model of the normal distribution. It's told us here that our standard deviation is 0.5. However, it's mentioned nothing about mean, so that is just mu, which we will need to find out. And then it tells us here, given that 2.5% of cut lengths exceed 50.98, so it's saying that basically when the length is greater than 50.98, it equals 0.025, basically 0.5% in decimal. And it tells us that strips with either less than this number or greater than this number cannot be used. So basically what can be used is anything in between that, which is this, right? The length must be in between these two values. So that is your probability that the strip of metal can be chosen. Okay, now we're going to find mu, which is our mean. We can't progress without this, and that's your first step when you've got a gap here. So what we're going to do is inverse normal, and this is what will come up. So this is your area here, and then to find the area to the left, you're going to do 1 minus 0.025, which gives 0.975. That is your area. Your standard deviation is going to be 1, and your mean is going to be 0. This is just to work out the z value, which is 1.96. Then you're going to use the equation, which is x minus mean over standard deviation. And if we plug that back in, we've got z equals 1.96. Our x is 50.98 minus mu over 0.5, which is our standard deviation. When we expand that, we get this, and then we get mean equals 50. So now we've got the mean, we can now work out the probability given here. So we're going to calculate this probability, and we're going to use our normal CD in our calculator, which is given with this. And for your lower, you're just going to put 49. For your upper, you're going to put 50.75. For your standard deviation, we've got that value here, 0.5. And for your mean, we've got that here, which is 50. And that will give you 0.9104. And that is your probability that a randomly chosen strip of metal can be used. Okay. 10 strips of metal are selected at random. Part B. Find the probability that fewer than 4 of these strips cannot be used. So the probability that they can be used was what we worked out in the last question, and that was 0.9104. So that was your part A. Now the probability they can't be used is just going to be 1 minus this, of course, and that will give you 0.08956. Now we need to find out the probability that less than 4, so 3 or less, cannot be used. So we're going to do binomial CD. We're going to do binomial for this question, and you'll get something like this that will come up, and you're going to put 3 because obviously x is less than or equal to 3. Your n is going to be 10. It says here 10 strips of metal are selected at random, and your p-value is given here, and then you get 0.991. A second machine cuts strips of metal of length x centimetres, where x is normally distributed with a standard deviation of 0.6 centimetres. A random sample of 15 strips cut by the second machine was found to have a mean length of 50.4 centimetres. Part C. Stating your hypothesis clearly and using a 1% level of significance, test whether or not the mean length of all the strips cut by the second machine is greater than 50.1 centimetres. Alright, so this is the hypothesis part, and for any hypothesis question, you need to state your null hypothesis. In this case, it's going to be your mean is equal to 50.1, and what we're working out is whether it is greater than 50.1. Again, that signifies a one-tailed test, so you can do mean is greater than 50.1 as your alternative hypothesis. Then we're going to set our information. We know that our mean is 50.4, as stated here. We know that our end value is 15, given by here, that's your sample size. And your standard deviation is said to be 0.6. Working out standard error again, that will just be 0.6 over root 15. And that will be 0.1549. And we need to find out the probability that x, or your mean, is greater than 50.4. That is what we're looking for. Now we're going to do normal CD in our calculator, and you'll get something like this come up. Your lower value is going to be 50.4, and then your upper value is going to be a very high number. The highest number we're going to do is 9,999. And then your standard deviation is 0.1549 given here, and your mean is going to be 50.1 as said here. And that will give you P equals 0.0264. Alright, so our significance level is 1%, that translated into decimals is 0.01, and P, our P value, is greater than that. So as 0.0264 is greater than 0.01, we do not reject our null hypothesis. So we can say that there's insufficient evidence to suggest the mean is greater than 50.1. So you always need to make sure to say whether you reject or accept the null hypothesis, and then you also need to apply it to the question's context. And yeah, that is it. That is the 2 questions done. I will do another part, but yeah. Thank you.